Welcome to everyone. So last day we have discussed what refraction through the spherical surface. Today I am discussing what lenses. So lenses means what? What do you mean by lens? Lens means what? You know it from class 10th level that lens is the bounded transparent medium, where one surface, that is the one surface is your curved and another surface may be curved or plane. Okay, may be curved or plane. Generally curved surface means what? Spherical, cylindrical, paraboloidal. So this type of called the curved surface. So suppose if I consider that one surface is curved surface and another surface is also curved, so this can say be lens. Okay, you can say this one is lens. Suppose if I consider this one is curved, this one is plane, you can also say this is what? Lens. So how many type of lens? All of you know. So there is actually two types of lens. One is the convex lens and another one is what? Concave lens. Okay. So convex lens is what? The middle portion is thick and two end portion is your thin. So this is called what? Biconvex lens. The first that I have drawn, this is your biconvex lens, right? This one is called plano-convex lens, right? And if one surface is your like this is the convex, and another surface is your concave, this is what? This is called concavo-convex. So this is, you know, and same way, how many types of the concave lens is there? So see, if this surface is your concave, this surface is your concave, so these are called biconcave. If one surface is your concave and another surface is plane, this is called your what? Plano-concave. These things you know. And if one surface is concave and another surface is your convex, okay, actually middle portion is your thin. So see here, if I draw like this way, so this is called your what? This is called your convexo-concave. Okay, so these are the two types of lenses, and you know from the class 10th level that convex lens has converging action and concave lens has what? Diverging actions. Okay, so I am not going into the details. Now next topics is my what? Next topics is your refraction through a thin lenses, lens maker formula. Very important, lens maker formula. Okay, lens maker formula. So what is the lens maker formula? So lens maker formula is your 1 by f is equal to n minus 1 into 1 by r1 minus 1 by r2, where r1 is the radius of curvature of the first surface and r2 is the radius of curvature of the second surface. N means what? Refractive index of the material of the lens, and f means your focal length. So here f is your focal length of the lens, r1 is your what? Radius of curvature of the first surface, radius of curvature of surface 1, and r2 is your same radius of curvature of surface 2. Okay, and n is your refractive index of the material, of the lens material. Okay, so material. So this is the lens maker formula, and how you can prove. So here if you want to prove, so you have to take assumption. So what is the assumption you have to take? One is the small aperture, okay, aperture. Next one is what? Lens is very thin, very thin, okay. So this is very thin lens we are taking. I mean, object distance and image distance is very larger than the thickness of the lenses, okay. Next one is what? We are taking here the point object we are taking. Next one is your what? Incident and refracted ray makes small angle with principal axis, okay. So these are some assumptions regarding the lens maker formula, okay. So to prove the lens maker formula, so you have to assume these things, okay. We have to prove the lens maker formula. So see here, so now this is the lens and this is the optical center. I am writing O, okay, or C, optical center. Here I am writing what? C, okay. Next one is your what? This is the optical center, and see, this is your, here I am drawing now the principal axis. So the principal axis is your what? Your principal axis is your, this is the principal axis, this is the principal axis. Now this is your first surface, this is your second surface. So first surface has pole P1, second surface has pole P2, and if you draw the sphere with second surface, then center of curvature of the second surface is here, and if you draw a sphere of the first surface, then center of curvature of the sphere will be here, right? Now if I consider the object, so object we are taking here what? Point object, okay. So this is the point object. Now so if this is the point object, now O, from the point O, this is the incident ray. So this incident ray is your OA, right? Same way it must passing goes through the refractions. So see here, this is the AB is the refracted ray, right? Next one is what? If second surface is not exist, if I consider second surface is absent, then this AB ray will just here going through the straight line and meet at any point on the principal axis, right? Suppose this is your I prime point, it meets, but actually the second surface is exist. So due to the refraction from the second surface, so also the light is suppose meet at which point? I point. So now here we have to assign object distance, image distance and radius of curvature. So here I am assuming that. So see, what is your object distance for the first surface? Here I am writing for surface 1. See, this is the rarer medium, it has refracting index N1. It is denser medium, refracting index N2. Again it is rarer medium N1, and the thickness of the lens is your T, and T is very small, okay. So for surface 1, here I can write N2 by V prime minus N1 by U is equal to N2 minus N1 by R1. Now what is this V prime? So U means what? U is your P1 to O, this is your U, okay. From P1 to O, this is what? This is your object distance. So object distance is your, for the surface 1, U is equal to your P1O, okay. Now radius of curvature will be what? P1 C1. P1 C1 is your radius of curvature. Okay, and image distance is what? From P1 to I prime if second surface not exist. So this is known as P1 I prime is known as, here I am writing P1 I prime is known as your V prime. Okay, so these are the distance of the first surface. So n2 by V prime minus n1 by u is equal to n2 minus n1 by r1. So this is your, you can put at equation number 1. So if I ask you what is for the surface 2, for surface 2 is this one. For surface 2, what is the object distance? See, for the second surface your object will be I prime. So for the second surface P2 I prime is your object distance. So here I am writing for P2 I prime, this is your object distance. Okay, this is your object distance, and your object distance is equal to what? Very simple, this is your P1 I prime minus P1 P2. So P1 I prime means your V prime minus P1 P2 means what? T. But this distance V prime is very larger than that of the thickness, so I can take it as V prime. Okay, very nearly to the V prime. And same way, if I consider what is the image distance for the second surface, image distance is your P2 I, this is your image distance P2 I, and this is equal to your V. P2 I, this is equal to your what? V. Okay, and what is the radius of curvature? Radius of curvature, that is equal to what? So radius of curvature is equal to your P2 C2 is equal to R2. Okay, now what we will write? So from here we can write, that is, for the second surface light is traveling from denser to rarer. So the equation becomes n1 by image distance is your V minus, this is your n2 by, that is what? V prime, because object distance is equal to your V prime, is equal to n1 minus n2 divided by what? R2. Okay, this is, you can put at equation number 2, right? As the rays are traveling from denser to rarer medium, so just interchange the refractive index. In place of n2, write here n1, in place of n1, write here n2, and the equation becomes this. Okay, so if you add these two equations, equation 1 plus equation 2, if you add these two equations, so what you are getting? So see, if you add, so that is equal to n2 by V prime minus n1 by u, okay, plus this is your n1 by V minus n2 by V prime is equal to what you are getting? Right side of the equation 1 is equal to n2 minus n1 by r1, okay, plus n1 minus n2 divided by r2. Okay, so if you can understood this one, so I can write the next line. So see which one is cancelling here. Here n2 by V prime and this n2 by V prime is cancelling. So here you can write this one very easily, that is equal to n1 minus n1 by u plus n1 by v. So I am writing it like this way, n1 by v minus n1 by u is equal to what? n2 minus n1 by r1, and this is n1 minus. So I can write n2 minus n1 by r1, no problem. And see here, minus if I take common within the bracket, so this becomes what? This is equal to your n2 minus n1 by r2, right? If you take minus common, so this becomes what? This becomes your, if I write this equation, okay, if I write here, so that is equal to n1 by n1, if you take common, then 1 by v minus 1 by u is equal to n2 minus n1 into minus n1, if you take common, then this will be your 1 by r1 minus 1 by r2. Okay, these things you can easily write. So from here what you are getting, so here I am writing this equation here. So this is what, n1 into 1 by v minus 1 by u is equal to this one, right? So 1 by v minus 1 by u is equal to what, n2 minus n1 by n1, right, into 1 by r1 minus 1 by r2. Okay, so this one is equal to what, this is the length formula, 1 by v minus 1 by u is equal to 1 by f. So and n2 by n1, this means what, n minus n1 by n1 means 1 into 1 by r1 minus 1 by r2. So this is the very important length maker formula. Okay, so this is your very important length maker formula. Okay, understood? So we have discussed the length maker formula. Now one question is that if we immersed a lens in water, question is that if the focal length of the lens is changed, yes or no. So let's talk about these things. So for examples, here if I consider this is the lens, and if the lens is placed in air, right? So this is the first surface, this is the second surface. So first surface has radius of curvature r1 and second surface has radius of curvature is r2, and refractive index is here I am writing, that is what, this is the air, this is the glass, here this is G glass. So which equation here you have to write, that is 1 by focal length in air, that is equal to air, this is the glass, so ANG minus 1 into 1 by R1 minus 1 by R2. This is your equation 1. Okay, now suppose the same lens is now placed, in water, so this is your water and this is what, this is your glass, right? This is the first surface, this is the second surface. So here you can write here 1 by Fw is equal to, this is water, this is glass, so you can write here Wng minus 1, same length, so radius of curvature is your 1 by r1 minus 1 by r2. This is your equation number 2, right? Now, so if you divide here equation 1 by equation 2, that is equal to 1 by Fa by 1 by Fw, that is equal to what? You can write here Ang minus 1 divided by Wng minus 1. This becomes your 1 by r1 minus 1 by r2, and this is your 1 by r1 minus 1 by r2. And see, this 1 by r1 and r1 minus r2 and this 1 by r1 minus r2 is cancel out, right? So you are getting here if W by Fa is equal to Ang minus 1 by Wng minus 1. Okay, now Ang means what? This is Ang, glass refractive index with respect to air is equal to your 3 by 2, and same way Wng, this is your 4 by 3. Suppose if you substitute the values here, this is your Ang, this is your 3 by 2 minus 1, and this is your Wng, this is what? Here I am writing one equation, that is your Ang by Anw minus 1. So this is your 3 by 2 minus 1, so this is equal to what? This is equal to your half, no problem. And Ang means what? 3 by 2 minus, okay, 3 by 2 divided by Wng means your 4 by 3 minus 1. So simply you can write here, numerator is your half and this will be your 9 by 8 minus 1. Okay, so this becomes your half by 1 by 8, so actually it will becomes 4. So Fw by Fa is equal to your 4. So Fw is equal to 4 times of focal length in air. So yes, suppose if you take focal length of the lens is 10 centimeter in air, so if you keep the lens in water, the focal length will be 4 times of it, that is 4 into 10, it becomes 40 centimeter. Okay, so this way the focal length is changed if you change the surroundings medium. Okay, understood? Now next, another things we have to talk some numerical problems regarding the lens maker formula is what is that, suppose if I consider the biconvex lens. Okay, this is the biconvex lens. One has radius R1 is equal to your 10 centimeter and R2 is equal to your 20 centimeter. Now what is the focal length and refractive index is your, this is your 1.5, that means 3 by 2. Refractive index of material of the prism, material of the lens with respect to air is equal to 1.5. So that is equal to what, which formula here you are using? Lens maker formula is equal to 1 by F is equal to n minus 1 into 1 by R1 minus 1 by R2, 1 by R2. But try to understand one thing. Suppose this is the object, if you keep, now see here 1 by F is 1 by F, n is equal to given. Here you have to note down the sign convention of the radius of curvature. So this is the object, and if this is the object, then incident ray is these directions, right? So this is the pole of the first surface, this is the pole of the second surface. So in this is pole, suppose pole of the first surface is here and pole of the second surface is here. So P1 C1 you are measure along the incident ray. So according to the sign convention, R1 is your positive, right? But for the second surface radius of curvature P2 C2, you are measuring opposite to the incident ray. So if you measure opposite to the incident ray, so this R2 will be your negative. So the equation becomes for the biconvex lens, this is your n minus 1 into 1 by R1 minus plus 1 by R2. Okay, so n is your 1.5 minus 1 by R1 is equal to 1 by 10 plus 1 by R2 is equal to 20. So this is equal to 1.5 minus 1, this is equal to 0.5 into, this is your 20 and this is your 2 plus 1, that is equal to 3. So 1 by F is like this way, and see F is equal to, that will be what, 20 divided by 0.5 into 3, that is equal to 1.5, and 20 by like this way. So this is equal to 40 by 3 centimeter, right? So for the biconvex lens, this is your formula. If I consider the same problem for the biconcave lens, same problem if I do, so that is what for the same convex. Now next we are discussing what, same example number 2, that is for the biconcave lens. So this is the concave lens, right? This is the first surface, this is the second surface, so it has pole P1, it has pole P2, this is your object. Now see, for the first surface, this is your center of curvature, so this is your R1, and for the second surface, this is your center of curvature, so this is giving you R2, right, radius of curvature. So object you have placed here, so that is your incident ray is this direction, is your incident ray. Now for the biconcave lens, the lens maker formula is your 1 by F is equal to n minus 1 into 1 by R1. At first I am writing minus 1 by R2, right? But see, incident ray is this direction, so R1 will be your what? R1 will be your negative. So if R1 is your negative, so you can write here this is your minus R1, right? And if you consider for the R2, yes, R2 is your positive. So the R2 is your positive. So the formula becomes 1 by F is equal to n minus 1. This is your minus 1 by R1. So that is what minus, if you take common, then within the second bracket if I write, that is 1 by R1 plus 1 by R2. Okay. So this is your formula, right? So that means you are getting the same things. This is minus n minus 1 into 1 by R1 plus 1 by R2, and already you have calculated this is your plus 40 by 3, and if you calculate this becomes your minus 40 by 3. Okay, so this way you can calculate the focal length of the lens. Okay, and if I consider another problem, that is the plano convex lens, that is equal to, this is the plano convex lens, right? So this is your first surface, this is the first surface, this is your P1, this is the P2. Okay, so see, for the plano convex lens, so this is your 1 by F n minus 1 into, this is your 1 by R1 minus 1 by R2. But try to understand, for the second surface, radius of curvature is your infinite. So you are just write n minus 1 into 1 by R1 minus 1 by, this will be your infinity, and this gives you only n minus 1 into 1 by R1. Okay, so this is giving you the focal length will be your R1 divided by n minus 1. So this is the relations of the focal length and the radius of curvature for the different cases. Okay, thank you.